Okay, a car of mass 1000 kg drives up a slope of length 750 meter and sine theta is 1/25. If resistant forces are negligible, calculate the driving force of the engine if the speed at the foot of the incline is 25 meter per second and the speed at the top is 20 meter per second. Model the car as a particle and use g equals to 10 meter per second square. Okay, I've drawn the diagram here. At the bottom is 25 meter per second. The velocity is 25, and then at the top the velocity or speed is 20 meter per second. Sine theta is given as 1/25, and the motion is forward. Okay, so this is where the motion is. Okay, so motion is forward, so therefore resistance will be acting opposite the motion. And since it's at the inclined plane, there is a force that's acting acting against the motion, which is mg sine theta. Okay, so we have to resolve that. Okay, now calculate the driving force of the engine if the speed at the foot of the incline is 25 and the speed at the top is 20. So first of all, let's find out what is the initial ME. Okay, which is at the bottom. Initial ME, we have KE plus PE. Okay, and since there's no height, we don't have to worry about PE, so that becomes 0. But KE, yes, half times by M, which is, what is the weight? 1000. Okay, the mass is 1000, it's not weight, mass is 1000. Half times by 1000 times by velocity, which is 25 square. Okay, so 625 times by 1000 divided by 2. So 625 times by 1000 divided by 2, and the answer that I have here is 312,500 joule. Okay, and next is the final ME, mechanical energy. Okay, final ME. Okay, it has reached a certain height. Okay, it has reached certain height, so therefore I need to know what is this height. Okay, if there's height, then it is none other than PE. So let's find out what is PE, and then since there's a velocity or speed, KE is involved as well. So mgh plus half times by mv square. M is 1000 times by 10 times by height. Height in this case opposite over hypo. Okay, opposite over hypo, and the distance of hypo is given as 750, so I can use that. So therefore we just use opposite sine theta equals to 1/25. So this is opposite, which is h over hypo 750 equals to 1/25. So therefore h equals to 750 divided by 25, and the answer is 30. Okay, 30 meters. So we just have to times it by 30, and then plus half times by m, which is 1000. Okay, and then times it by 20 square. So we add all this. Okay, this is 1000, so 10,000 times 30, which is 300,000 plus half, that's 500. 500 times 400, which is another 500. Sorry, it's not 500 times 400. Yeah, it is 20,000. Okay, so 200, 500 times 200,000, 000, and the answer is 500,000. Okay, so that's our final PE. Okay, now the question here, calculate the driving force. Okay, how do I find the driving force? Excuse me. Okay, calculate the driving force of the engine if the speed, okay, that's given. So driving force, so times by the distance is equal to work done. So I have to know what is the work done over here. So 500,000 minus 312,500 is the difference in ME. Difference in ME is the work done. Okay, so in this case we have $187,500 and driving force DF equals to 187,500 divided by distance, which is 750. Therefore the answer is 250 Newton. Yeah, okay, so that's the answer.